Hey guys, Mr. T here with another video. This one is on 3D solids, so pretty basic here. Hopefully it's a lot of revision. All objects that exist in the world around you are obviously 3D, three-dimensional. That means they have a length, width and a height. We call 3D objects solids, even if in some cases they're hollow inside. They still have a thickness, so we call them solids. Now, polyhedra is a term you'll need to be aware of. Much like polygons is the term for two-dimensional shapes that have multiple vertices and straight sides, polyhedron, and polyhedra is the plural of that, is the term for a 3D shape, 3D solid, that has only straight edges. So edges are the meeting point between the flat faces of a polyhedron, which you can see quickly here. So I've drawn, this is essentially a cube. The edges are the meeting place between the flat faces. So the flat faces here you can see in the cube are squares, and two squares meet at this one edge between them. Next, because the edges are straight line segments, so you've seen the edge, I've marked it out, there's a straight line portion. The faces of the polyhedron are going to be flat. It's not all curling around and stuff, so it's going to make the edge, the face stick out anywhere. It's a flat, it's a straight line. So this face is going to be flat because of that straight line edge. And because of this, the faces are all polygons themselves. So in a polyhedron, you've got straight line segment edges, and then all of the faces will be some sort of polygon. So if we look at a cube, the faces, how many of them are there? 1, 2, in the back 3, in the back 4, the bottom 5, and then the top 6. 6 faces, squares in a cube. How many edges are there? Well, there's 1, 2, 3, 4 at the top, 5, 6, 7, 8, 4 at the bottom, 9, 10, 11, 12. 12 all the way around. 12 edges. How many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. And I figure I'd chuck in a weird one here. And then whatever this is, this doesn't have a particular name. Kind of looks like a, I don't know, a church or something. The faces aren't all the same. Okay, you've got this weird shape here. We don't have a name for that, so I'm just going to count the number of faces. 1, 2, 3, 4, there's a fourth one on the back of that roof shape, 5 at the top here, 6 at the back, 7, 8. There's 8 faces. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 edges. Vertices 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 vertices. I don't have a specific name for that because I literally just made it up, but that's just an idea as how do you refer to faces and edges and vertices in a polyhedron. And this, however weird it looks, is a polyhedron. Why? Because it's got straight edges and all of these, the faces are polygons. Alright, the next idea we need to deal with is solids with a uniform cross-section. So a cross-section of a solid is the 2D shape that occurs when you slice through a solid. If a solid has a cross-section that's the same the whole way through the solid, then it's a solid with a uniform cross-section. So if we look at this shape here, if I was to cut it, say, in this direction, so if we go from the top and then slice down with a knife, down, the cross-section is going to be like this face here, sort of a rectangle. And if I did it again, slightly further along the shape, it would still be another wonky line there, another rectangle. If I cut it further down the shape, even further, it would still be a rectangle cross-section. So that is a solid with uniform cross-section. That is true for that one. That's versus this shape here. You can see the front face is a small rectangle, the back face is a large one. So it's getting bigger as you go in that direction. So if I cut here, you would have a small rectangle cross section. If I cut in the middle here, it would be a slightly bigger rectangle. If I cut at the back, it would be a larger still rectangle. So that is not a solid with uniform cross-section. So not a solid with uniform cross-section. Also be aware that you can cut in the other direction as well. What if we cut along that way? Well, if you think about the bottom of this thing, if I was to cut that way, your slices would be a large rectangle. Not quite drawn correctly. And if I cut it at the top there, it would still be another large rectangle. If you thought about this shape here, on the right side, if you cut along there, your cross-section would be a small rectangle. If I cut slightly above that, it would be a large rectangle. If I cut right in the middle here, it would be the largest, not even a rectangle. They're not rectangles because they point inwards. There's trapeziums, sorry, not rectangles. And if I cut in the middle, across the middle there, it would be the largest trapezium shape. So in both directions, this shape here is not a solid with a uniform cross-section. Now, why do we have to talk about uniform cross-sections? Because prisms are a special type of polyhedron. Any solid with a uniform polygon-shaped cross-section is called a prism, and they're named according to the polygon-shaped cross-section they have. So if you look at this shape here, if I was to cut down there, for example, the cross-section shape you're going to get out of that is the end triangle. So the cross-section is a triangle. So it's called a triangular prism. If I was to cut along there and along the end there, your cross-section is going to be sort of this rectangle shape all the way through. So the cross-section is a rectangle. So it's going to be a rectangular prism. And this shape here, if I was to cut sort of along there, your cross-section is going to be that sort of house shape on the end there, which is a polygon. It's a pentagon. So, pentagon. So it is a pentagonal prism. Alright, so that's the idea of prisms. It's any 3D shape where if you cut all the way along it, it's the same cross-section all the way through. Next is the idea of pyramids. So pyramids are 3D shapes with a polygon base and an apex, which is a single point above that base. The faces, because of this, are triangular, and they form between edges that go from the base up towards the apex. So here we have an apex, here we have a base. It looks like a rectangle. So in a pyramid, edges are formed going up from the base to the apex, base to the apex, base to the apex, base to the apex, and you'll notice that these faces are all triangular. So that is a rectangular based pyramid. So what makes these pyramids is that they've got straight line edges. Here you have another type of pyramid. At the bottom is a triangle. You have edges forming from the base to the apex, base to the apex, base to the apex. I could have drawn that line better. So that is a triangular based pyramid. So that's just a quick going over of what a pyramid is. Solids with curved surfaces. So now we're dealing with curves. 3D solids with curved faces all have their own special names. So cylinders are like a prism. They have a uniform cross-section. The problem is they're not a prism because the cross-section is not a polygon. It's a circle. So this is a cylinder here. If you were to cut a cross-section through it, at the one end, at the other end, it would always be a circle. So that's cross-section is circular. Therefore, it is a cylinder. And the next idea is cones. Cones appear similar to pyramids. They have a base and an apex. The problem is the base is circular. So really there is only a single curved surface that connects the base and the apex of a cone. Unlike with the pyramids, I can't just draw one, like a few lines from the corners of the base up to the apex, base to the apex. There's an infinite number of points around that curve. There's an infinite number of corners. They form one continuous curved surface going from the base to the apex. And generally, if you're not so good at drawing and you want to discern between a pyramid and a cone, you want to shade in a circular fashion one side of the cone to try to make it obvious that it's curved all the way around. And the last shape we need to deal with is spheres. Spheres are simply ball-shaped solids. They're special because they have one continuous curved surface all the way around. So yep, it's a ball. Right now it looks like a circle, so if you're drawing them and you want to make sure that it's obvious it is a sphere, then remember back to your Year 8 art class and do some shading. So do sort of like a moon shape of shading around the edges to make it obvious that there's something going on with this circle. It's not just flat, it's three-dimensional, it's shaded, it's curved. One curved surface all the way around, it's a sphere. Alright, so hopefully that helps you out with just some of the basic ideas of 3D solids, and I will see you in the next video.